If you recall from last year, if you were with us last year, Ashley was leading a workshop on how to go about improving your odds of getting funding for a graph project. So Dave mentioned that in his little summary there, and it was extremely well received. In fact, what I'll do is I'll drop that YouTube link into the chat. And I also want to provide just a special thanks for Ashley for stepping in last minute as our presenter that fell ill, as I mentioned earlier, in the middle of last week. She's filling in. So she'll be detailing a little bit more about how taxonomies, semantic tools, and knowledge graphs interrelate with machine learning techniques as a natural accelerator. So if Ashley's on, the floor is yours.
Let me share my screen so we can get started. But for those that don't know me, yes, I am the host of the Is a Data Thing educational YouTube channel where I do have a day job that I do all of this as well. But the primary area that I kind of educate out of is my YouTube channel, where we talk a lot about semantics and knowledge graphs and, how do you wrangle the data to get where you want to go. So if you're interested in learning more about that, go and check me out over on YouTube. It's just under my name. And with that, let me go ahead and get started. Okay, so today we're going to be talking about semantics, and that does get to be a squishy word at some point, but in this presentation, we're going to be talking about this from a perspective of taxonomies and knowledge graphs. So what are we doing with the semantics in those to help some of the machine learning tasks that a lot of folks have at their organizations? So that's what we're going to talk about today, is what are some of those characteristics and methods for retaining, adding in, and reusing the semantics that you already have or that exist out in the world for machine learning or machine learning techniques. So that might be using pre-trained models if you already have them. This could even be applied to some of the off-the-shelf commercial like auto indexer kind of things where you're auto classifying documents. This is just generally how do you help the machine learning that you're using, whether you're making it yourself or getting it off the shelf, to make it a little bit better. Okay, so why does context matter for machine learning? So yes, we all know about the chat thing that's going on right now. This stuff has been going on for a long time. I'm sure you all know that. It's not just the most recent chatbot. Context matters though, and a lot of what goes into machine learning is highly dependent on that context. So here, the hierarchy and metadata such as definitions in your vocabularies or in, again, off the shelf, if you're getting something from, name your provider of taxonomies, there's a lot of metadata that you can use to actually provide some of that context in machine learning. So here's a good example. So I was using AWS Comprehend to just extract some information from full text that I had in academic research articles. Now you'll see here, weights is one of the things that was pulled out. But weight has a ton of different contexts. So on its own, in its very short and small data set, it doesn't have enough context to understand what kind of weight. So that's where that context would be helpful. If you have a small data set or a data set where you have a lot of ambiguous terms, your taxonomy has very clearly defined, and your knowledge graph very clearly can define what something means. And so that's one area you can use this. Now, switching over to the categorical and over-indexing use case. This is something to kind of watch out for. And you'll hear a lot of that in this presentation. It's not just how can you use the taxonomies and knowledge graphs that you may have, but what to watch out for, because they aren't all used or developed for machine learning. So sometimes you have to watch what you're feeding into the machine, because garbage in, garbage out, or bad context in, bad context out is appropriate for this conversation. So here, unfortunately, the Google academic research branch is no longer, but and that's not Google Scholar. This is something else where they had a lot of research in this free and open area you can go and dive into. But you can see here that the highest amount of publications coming out for this domain, which was the healthcare domain, actually is talking about history. because there was a lot of over-indexing happening. And so that context was missed because over-indexing means that someone, somewhere, or some machine added way too many tags to the content and it oversaturated and made the article or the asset seem something that it really wasn't. So that's another area where if you are generating taxonomies or knowledge graphs or machine learning models off of unstructured text, you have to be very careful that the machine has enough data and not too much data where it goes in the opposite direction that you don't want it to go. And then the other here is religious context versus the written language context of Jodo Scene. That is something where the metadata would be helpful here to understand the context of this specific thing in a knowledge graph. So adding in that context is going to help the machine get better at what it does. So what is the difference between taxonomy and a knowledge graph? So first of all, there's a lot of different types of knowledge graphs. So I'm not going to go through all of those in this presentation. This type of knowledge graph I'm talking about here is still talking about a relation between two different nodes. And in this case, the nodes are more like a taxonomy term. So that's a big difference here, where you can see that the taxonomies are really talking about the aboutness of a thing. They are really created for either a browse function like you would see on an e-commerce site, or the aboutness tags on what a certain asset is about for discovery or finding something in a search engine. And so you can see here how the different relations are really what are setting these apart. So a knowledge graph in this context is talking about the search engine optimization of an embedded graph so that you can understand how two things are related. So you can see here, The Great Gatsby is about the Jazz Age. And then a knowledge graph would say instead, Rome is a capital city of Italy. See, the relations are a little bit different between the two. There's a lot of other differences, a whole video on my channel all about that. But for the context of this, that's the definition we're using here. So why not just use these two things as is? Well, first of all, they weren't made for that. A lot of taxonomies and knowledge graphs are not necessarily made for machine learning. So you have to understand maybe where to be careful about the information you're putting in. And if you are on the taxonomy and knowledge graph side and you're hoping it can be used by those on the machine learning side, this is something good for you to go through and really analyze, maybe like a health report on your taxonomy or your knowledge graph for the use in machine learning. Doesn't mean you can't have these things in your taxonomy and knowledge graph. It just means if someone's using it for machine learning, you should probably give them a heads up. So most linked data sources are made for a particular use case. And this is something that you can see in the linked open data cloud, where they're either very specific or they're so general that they're more like an upper ontology kind of thing, where it's very general so that it can be used in many different applications. Many of them have errors, misalignments, offensive content, because not all of them have ethics or review in place, because a lot of them are maybe open source. And while, yes, you can get a lot of feedback from the crowdsourced approach, if you're the one who trained it before the crowdsource caught it, you're going to be in a world of hurt. So you definitely want to have some checks and balances in place if you're on the machine learning side, just in case the taxonomy side or the knowledge graph side didn't get updated soon enough. So this was actually shown in a recent MIT study where the most popular ML data sources had a pretty high error rate. And one very popular, and I won't mention it, source had 54% was wrong at any given point. So be careful when you are going through and using anything like this in machine learning. Linked data still does need merging and deduping. It's not a silver bullet. You definitely have to still do mappings and munging and deduplication of what you're seeing. And if you have a specific schema, or you are maybe using something outside of English, many of these are in English, not all, but many are, you do have to do some more munging of the data to get it into your system and to make sure that your machine learning models can read it. Linked data has different levels of trust. So this is where that provenance comes in. If you don't necessarily know where a data set comes from, be aware of that, because you have to really mitigate that risk in some way. So as an example, if you're training a model on all of the internet, there's a lot of weird things on the internet you don't want your machine to learn, right? We've seen many instances of that happening. So that's where you have to just be very aware and very careful about what we're putting into the system. Many linked data sources are more on the library and scholarly type side. These are very likely in maybe schemas that you're not familiar with. So this would be like a MARC record, or maybe something that is like in Dublin Core. I know Dublin Core is pretty well known in the linked data space, but if you don't know about that, a lot of it does come from that librarian background. So some of it you might have to actually go in, and even if you understand it, the machine learning folks probably don't. So you need to translate for them. And so here are some examples as to what you might see. And these are all real examples, by the way, where I had to do a machine learning project and I was using taxonomies, Library of Congress subject headings, for instance. And this is what we had to do. So dog dash dash food dash dash recipes. That's what you would see in a typical library that was using the Library of Congress. Machines are not really going to do well with that, because it doesn't have enough context. It doesn't really understand what's happening there. And so you can see how we have to then translate that. So be aware of some of those things when you're going through and looking at your own taxonomies for use in machine learning, or if you're using outside ones as well. All right, so here are the common areas to watch for. And why do these exist at all? So first, outdated terminology. This is I love taxonomies, but this is one of the areas that is really hard, because taxonomies are traditionally based on the assets that you are tagging it with. So if you don't have assets on something, you might not have the word for it. Well, guess what? Content is coming in, assets are coming in, and you don't have the word yet. So it's almost like you're kind of trying to see how much content you get in before you add the taxonomy term, so that you can then start adding it to those assets. But that means sometimes the terminology is outdated or doesn't exist in taxonomy. So be aware of that. Knowledge graphs can update a lot faster, I would think, than your traditional taxonomy. Again, not all, but just be aware of that. Some outdated terminology. And not just that, like when you look at that provenance, there's a lot of historical notes, or when was it last updated, that sort of thing you definitely want to pay attention to, because there are some terms that are just terms that have been around forever, like a diesel engine. Diesel engine is a diesel engine. It's been one for a very long time. An electric engine, however, has not been classified the same. This actually, again, happened to me, real life. I was working on some historical magazine articles from the Society of Automotive Engineers, and it was talking about electric vehicles in the 1930s and 40s. I was like, whoa, what? That's weird. I looked it up, and what they were meaning was it was an electric start, but they called it an electric motor. So you have to be careful about these things, because again, depending on when it was updated or what assets it's being associated with, it's going to change that context. Fuzzy, broader term, and narrow terms. So this is where sometimes you'll get, especially taxonomies that are very big, sometimes they have fuzzy relationships between how that broader term is related to. Sometimes the broader term is what I would call a dummy term, which means it's just there so that you have a place to kind of put a family of terms and cluster them together. And what that means is sometimes it doesn't really mean anything other than these things all have something in common. So just be aware of that. Scope notes and definitions. If you look at, especially the one on the screen here, scope note, definition, same exact thing. You know why? Because it's very poorly defined what one should be used for. Traditionally, you would use a definition to use as the official, like Merriam-Webster, kind of how a person would define this thing. Scope note is supposed to be how an index or machine learning auto classifier should use and assign the rules for assignment. Very few people use them that way, though, but that's officially how you're supposed to do it. So be aware. People kind of mix them and match those all the time. So bad form. So this is like, again, things that you would see with like names where their first name would be their, like the last word. So it would be, for me, Faith, comma, Ashleigh. A lot of machine learning can, because that's so common, revert that, but just be aware sometimes the form, a good example of this is where in taxonomies, you'll have a parenthetical. So Jupiter, the planet, Jupiter, the Roman god. That part, the machine isn't going to really understand what that means. So you kind of have to teach it or take that out and put it back in as context, because that's really what it is when you're working with a taxonomy. Over-indexing, again, this one, look, this example here, this one article, the plastics and environment one, this was only a 3 or 5 page article. Look how many tags are on this thing. This was a lot, where they're putting like parts of the metadata in there. This article is not about Sam Wells. It was written by Sam Wells, right? We're all metadata people here. We know why that's not good. That's not what this is about. That's who wrote it. So making sure that you really look at some of that, because not everyone follows the same indexing practices. Circular logic. So you'll see that in the Excel looking one, where if you have a very large vocabulary, sometimes you'll accidentally make a parent, a child of a child of a child, the parent somewhere. So it'll give it like some circular reasoning. So you need to be careful of that. Categories versus specific tags. So what is this about versus this is a general family of things. Unknown, unfriendly context or schema. We already covered that a little bit, where not everybody uses standardized schema, unfortunately. We all know they're out there, right? But not everyone uses them. So be careful of that. Everyone likes to add in their own exceptions. And then overly unique terminology. So as an example, there was one taxonomy I was working with where they had a term. This wasn't that trademarked is different. That is perfectly acceptable. It's a trademark term that somebody made up and it's a thing. Whereas others are just making up words they want to use. Piano violin is the example I found in a vocabulary I was working with once, trying to get the machine to understand what that meant. I asked the indexers, hey, what does this mean? They didn't know either. That's a problem. So be aware of some of these things when you're looking at your own taxonomies or taxonomies you're trying to reuse. All right, so what to look for. This is maybe something you can go and do with your own taxonomy or taxonomies that are out there for everyone else to use. Something like VIAF or BioPortal are good examples to go and look at. So some check marks here. Provenance and ethics. If this chat stuff hasn't taught us anything, it is provenance and ethics. Can I say it louder? Like, we need to know where the data came from. Who was represented? Do they know they were being represented? Are they okay with that? Did we get the data right? Are we making sure that protected groups are not involved in that data set? All of these need, do we have the rights to use this data? Just because you got it, from the web doesn't mean it's totally open and free. These are things that you would think are common knowledge. They are not. Information literacy needs to up its game because I have worked with way too many folks on the machine learning side where they don't get this stuff at all. And that's scary. So be aware, be the person at your organization that's asking those questions. Also, looking at UIDs and APIs. So the UID is to give it a permanence that this thing exists and it's unique and it can be called from many different things. That's where the APIs come in, making sure the data can actually be used and accessed by not just your own cohort of folks using it, but also others. If you so choose, doesn't mean it has to be third parties outside of your organization even. Making sure that the sales department can still use your data, even though you're the content space, is probably a good idea because it might be good that you all use the same words, right? Or the same models for disambiguation, right? Pre and post coordination. This is a very librarian-esque thing, but pre-coordination is not as good for machine learning as post-coordination. So pre-coordination means that you are taking two different taxonomy terms and sticking them together. So as an example, cybersecurity standards. That's a pre-coordination. Those are two distinct kinds of things that you need the machine to understand. Now, again, it depends on your use case. Maybe cybersecurity standards is a unique concept to you and your assets. That's fine. You kind of have to play around with what you're actually using this stuff for to understand how you want to structure it. But post coordination is basically where you can mix and match more in your vocabulary, and then that helps the machine learn. So instead of figuring out the combo term and all the nuances of that, And that's where maybe rule-based machine learning might be helpful for you. If you're doing post-coordination, what you're doing is you're training on each distinct concept. So when the machine sees those distinct concepts coming together in one article, it knows it's about both. That's why it's helpful for machine learning. Definitions, not scope notes. So definitions are going to teach the machine the context of this term. How you have rules around when something is tagged to content, that's where you want to use your scope notes. And you can use that if you're using auto classification, by the way. You would just be noting maybe which model is doing the tagging. Maybe you have a different model for content type versus the actual what is in this article. Again, have those as different fields, but that's where you can put things into scope notes. But definitions are much better for that context piece in the training of your models. You need to really understand sensitive topics and how historical data is handled. So not that long ago, the term illegal immigrant or illegal alien, I think, or something was permissible. That is not appropriate anymore. So you have to be aware if you start to see some of that data crop up, especially when terminology and the appropriateness of it is changing and getting updated. How many ingoing and outgoing links? So if you have a ton of incoming links in your link data source, that means that you have potentially a higher confidence because it means a lot of other vocabularies are agreeing or have a similar concept. If you have a lot of outgoing and not a lot of incoming, that doesn't necessarily mean bad. It just means that your vocabulary is being used by many, many other people, and you're kind of setting the stage. So you have to be aware of that. So most people are kind of in the middle, but if you're on the extreme of either side, you have to be aware of it because you're going to have a very different impact on all the other vocabularies you're using and the machine learning that is put onto it. You also really need to understand who is maintaining the data and its data governance. I'm sure everyone in this audience has heard many things or will hear many things in this conference about those topics. And it doesn't mean that you have, one person to rule them all or even a cohort kind of assembly of people, like a working group that decides everything. You have to decide what data governance model is going to work for you. But you do need to understand who is maintaining this stuff if you're on the machine learning side, because you need to make sure you know who your partner is and ask them, oh, is this the right context? Can you check this? Did we get this right? And if you're on the taxonomy side, you need to know the data governance that's going on with machine learning. Guess what? Probably doesn't have any. So maybe you should educate them on that. Again, I'm kind of being a little mean on the machine learning side. I don't mean to be. I just know from my experience, it's in its infancy. So just be aware if it's all set up at your organization, you're lucky. But many are struggling to get up to speed on these things.
You also need a question in the chat if you want to take that now.
I cannot see the chat, so if you can tell me.
I can read it to you.
Yes, please.
It says, Ashleigh, you highlight provenance. How often do you run into scenarios where temporality should be in your top 10 what to look for issues? Perhaps it's part of number 5, sensitive topics / historical data.
Yes, absolutely. It's very much in the sensitive topics, more on the historical data side. What I like to do is for data governance, certain terms that are more on the sensitive side. And how do I define that? So I actually use the same definition that IRBs, institutional review boards, use. And those are, if you're not familiar, ethical review boards at all universities that kind of review the studies that are coming out from a university to make sure that they are ethical and they're not hurting anyone. And so IRBs kind of walk through certain protective groups, certain ways that you should portray and explain what you're doing to the folks that are in your study. Kind of the same thing here, where if you're talking about things, some sensitive areas are like anything that is defining the person, right? So how they identify, what religion they have, their gender, that kind of thing, politics, what their political stance is. Those are usually protected. Children, of course, are protected. Pregnant women, anyone that is incarcerated, or someone that has some additional things that they have to work through to make decisions. There's a whole bunch of stuff. Go look at your local university. They have an IRB training that you can actually go through. Those are all areas that I would consider sensitive. And it's because if you get it wrong or if you misconstrue it, you're hurting someone. And it doesn't physically have to hurt them. It could hurt how they are portrayed or how their people groups are portrayed. So that is a big part of it. And those should be in your data governance on a faster and more often review cadence than other terms. And when I say terms, I mean your taxonomy terms or your knowledge graph nodes. They sort of have to have, this is just the data governance I follow. They all should be on a review cadence, that they get reviewed at least once a year. So again, diesel engine is diesel engine. It's not sensitive. So maybe you look at it once a year and just make sure it's okay. But other things you do need to be more cautious with. So that's how 3 things on this list kind of merge together. All right. So, but thank you for that question. You also need to understand where the root source of the taxonomies come from and the knowledge graphs come from. So if you're doing things more on social media, those are going to have a wilder cadence of like ups and downs because social media is like constant, whereas scholarly articles, it takes a while to get those things published. So it depends on how much you have to refresh the data. And then you do need to understand whether it's a general vocabulary. So I would say like Library of Congress is general because it's supposed to be used by most people in English speaking countries. And they have different countries have variations of the Library of Congress, but it's kind of that. It's specific or it's general because it's supposed to be used by a lot of people. Whereas specific domains might be like I had in a previous slide, the Transportation Research Board. It's very specific. It's supposed to be for things that transport people. And so that is very specific and it helps you understand how trustworthy the definitions of things are. Because if you're looking at something that's general, they're just going to have a general definition of what electric vehicle means. Whereas some vocabulary that's their bread and butter, they're going to have a very tight definition of what that is with more nuance. Doesn't mean one is better than the other. It just means you have to decide that based on your use case. And then, of course, the schema and the framework to understand if that's going to work with what you're doing and how much effort you have to put into doing the mapping. So what to do if your own data is missing context. So there's quite a few things on here related to machine learning. So if you are not a machine learning person, take a screenshot of this and give it to your machine learning people because they'll understand what a lot of this is. So the general areas, though, are on the bottom here where you can see if you are starting to add in more context either from a taxonomy or a knowledge graph. So your node attributes or your taxonomy term attributes, right? And that's how you would translate this. That's looking at the characteristics of similarity. And then there's some methods here that I have that you can go and try. These are all machine learning methods. You can use all of these in open machine learning libraries, by the way. You just put it into Jupyter notebooks or whatever and run it. Then you have your structural features. So this would be like the relationship between the taxonomy terms. So like the hierarchy, even your use for and synonym kind of relations. And then in a knowledge graph, it's the explicit edges between the nodes. That's what you would be looking at there. And then the node embeddings is more about, in the taxonomy world, the relationship between the terms that have like a see also kind of thing, right? So this term is very related to this other term, even though they don't belong in the same hierarchy kind of thing. And then on the knowledge graph side, that's like the cluster of like-minded things. So if you would zoom out from your graph, it would be like the tight clusters of things that you would see. So how do you add in context? That is how things are related to each other. So that's the context of it. Now, of course, there are other things in this methodology area that like top to vec, doc to vec, node to vec, lots of vecs. That's all on unstructured content, right? So you can analyze the data sets themselves for context, but you can also use your unstructured text or text from the web to help you with this. Okay, so retaining or recovering your context. So I have a ton of resources here that you can go and check out if you would like. So just going through the list here is how do you add it back in? So using existing linked open data, very context rich, right? There's a lot of them out there. And the linked open cloud that I had early in an earlier slide, that's probably a year out of date. It's huge now. So there's a lot of great stuff out there that you can go use. Again, with the caveats that we've already gone over to make sure you're using it appropriately and you know what you're putting in. Link your data sources. That's going to be helpful. And I also know that that sounds scary to those that are probably in an enterprise of some sort. And that's okay. It doesn't link data. Notice I didn't say linked open data in this one, because you can link your data and it can be reused at your own enterprise. It doesn't have to be used outside of your own walls. So make sure that your data can be used by others. By the way, that gives you a higher ROI, which means when you have to make cuts, you can say, hey, don't cut this thing because it's worth this much. Just a heads up. That was in my last presentation at this conference last year. Looking at adding in types and categories. So types and categories will help anybody in the machine learning space zero in on parts of your taxonomy or your knowledge graph that they want to use. So if you have a large vocabulary or a large knowledge graph that's focused on people, maybe some of those people are authors versus those that are mentioned in the, or maybe cited by, right? So understanding the type, or if you're looking at topical things, it could be this domain or category is all the medical stuff, and this over here is all the legal stuff. If I'm training my model, those are very different contexts. It would be really helpful for anyone on the machine learning side to know, wait, here, divide and conquer here. Like get the machine learning going really well on medical, or get it going really well on legal, and then you can bring them together and they make a beautiful, happy, good tagging baby. So that's where those are really helpful. Confidence scores. This is incredibly helpful when you are doing anything in your knowledge graph. If you have the confidence of maybe how many inbound vocabularies agree with you, or maybe you're outbound and you're saying, well, this is how many vocabularies are using our data, or maybe departments, right? Like how many departments are using it. So that inbound and outbound can be like departmental focused. And if you're on the machine learning side, or you're working with the folks on the machine learning side, ask for those. It's either going to be a cosine or some kind of similarity confidence score. So cosine is going to tell you how similar the two things are. And then a confidence score is how well the machine, it's like the report card for the machine, right? Like you train it, you teach it, and then it spits something out and says, how well did I do on my test? That's what you really want to look at, because first it helps you prioritize which taxonomy terms or knowledge graph nodes you're looking at, or parts of your graph that you're looking at to fix something if the machine learning went awry. But it also helps you talk to each other, because a lot of the time on the machine learning side, they don't always get what a taxonomy and knowledge graph does. So you can actually start to walk through them just as far as the output of the models, which is the confidence score. And the data governance, right? Like that goes into it too, which is, okay, well, this thing is outdated. That's why your model's wrong. And they come back and say, hey, these ones are wrong. Why are they wrong? You say, well, you use some sensitive topics and those, right? So it's kind of like how you make a communication line. And then ML results are only as good as the search or user deems them. So you need to make sure that you are doing some A/B tests, because there's a common misconception, and it's prevalent, so prevalent in all of the taxonomy space, at least. And that is, there is a preferred term. I want to kill that so bad. There is no such thing. There's no such thing. The word I use for something is just as valid as the word that you use for it. So calling it a preferred term is kind of like rude. So if you're talking to your users, and they could be internal users, right? And they use a different word for something, how many of you have tried to convince them their word is wrong? How well did that go? Probably not well, right? So it's okay to have a standardized label. That's 100%. You need that. But what you need to do is talk to your end users, the ones who are actually using what you're outputting, using either the taxonomy, the knowledge graph, or the machine learning. Whatever output is going to people somewhere. And you need to make sure that you really understand how they talk about things and how they label things, so you can put those in to the data sets, and the machine can learn from them. So retaining, register your UIDs, of course. The provenance and ethics, if that goes off the rails, you can get into a lot of legal trouble. You can get into a lot of harmful situations where you've actually harmed your end user or your end customer. And again, that could be an internal end user or customer. You have to be very careful about these things. Test and test again every few months to make sure the data is still sound. Machine learning is not a set it and forget it. And by the way, neither is knowledge graph and taxonomies. I think taxonomies sometimes just grow and the older stuff doesn't really get looked at. Please stop. Please don't do that. Please put some kind of data governance in place where stuff gets looked at sometimes. And with a knowledge graph, sometimes they get too big for some of this. So putting things into an automated or manual review cadence is incredibly helpful to help with some of this stuff. And then train your
Another
indexers.
chat question. Oops, sorry.
Yeah. No, go ahead.
How often do you suggest communication between ML engineers and ontologists or taxonomists? Is an agile approach preferred?
So I don't know what agile approach would mean here, other than the way that I've always structured. I've always had both the ontology, taxonomy, knowledge graph folks with the machine learning folks on the same team. And if they can't be on the same team, they are in daily stand-ups with each other. Now, they won't always understand what each other is talking about. So you have to kind of figure out if it needs to be every stand-up or if it's every other, or maybe there's you focus on one group versus another in whatever stand-up you're doing. But one thing I learned very early on, it was drilled into me in my advanced semantics courses, they are two sides of the same coin and they have to work together. One is realizing all that context, all that subject matter expertise, and the other side is making it more actionable for the machine learning. They have to talk together. So early, often, and very quickly is what I would say.
Good. One other question. Have you seen experiments in overlaying good existing taxonomies with one of the big world vector models, seeing if that helps with some of the difficult problems, for example, pre and post coordination, composite concepts, and the like?
So I have seen, so to answer the first part of the question, adding in taxonomies and knowledge graphs to a lot of the big open world language models, yes, 100%. Be aware though on who can see your data, because you don't want to train, and I'm not even just talking about the big ones everyone's talking about. Even if you're working with like a vendor that does auto classification and they maybe have a knowledge graph and you're kind of supplementing with your taxonomies or whatever, be very aware of how your data is used in their stuff, because you don't want them to benefit from your stuff and you don't get credit for it, right? So be careful. But yes, that's very, very common and very useful. Now, as far as the pre and post coordination, that's hard. The problem is you can do some weird string matching kind of stuff, but it takes a lot of effort to get something from a pre-coordination to a post-coordination. Unless, and this is where I would go if you're in that boat, is there's usually rules somewhere that the indexers, like human indexers, have to use. Like in the medical domain, this is very common, where there's like child term and parent term and tertiary term and all of those things. There's rules around that. So instead of going into the vocabulary and trying to figure it out, use the rules and try to automate the parsing that way with the rules. That's how I've done it in the past. All right, so yes, and the last is train your indexers, your DAMs, your CAMs, and your ML engineers. So that is, I'm glad somebody asked the question about how do you keep that communication going. That's what you do. You need to make sure that you're having this conversation that we're having right now with both parties, because oftentimes they don't know what's going on in the other camp. And, there's a lot of hesitancy on both sides to learn more, because they either don't get it, they don't understand the importance. They're like, yeah, I can figure it out all on my own. There's a lot of misconceptions. So, try to be that data therapist that I always talk about. If you haven't seen all the way other stuff, I talk about data therapy all the time. That's where you can step in and start to help those parties talk to each other. All right. So let's talk about how do you actually do the mapping models if you need to add in other vocabularies or things that the machine is actually spitting out. So here, right? So the considerations, you can see the SMEs have to be there, right? The folks that are SMEs on both sides have to be there for this. And looking at the hierarchy, looking at the context, all of that will help you do mapping. And mapping doesn't have to be manual. This is just the way that you can do it. So one side is a crosswalk, which is you're doing a one-to-one mapping constantly. And as you can see, once you get past 3 vocabularies that you're mapping together, or 3 data sources, it could be like schema, for instance, it gets gnarly really fast. So that's where a hub or graph-like model with the data meshes that are out there and data fabrics. Yes, Alan, there you go. You got your shoe in for later conversations. But that's where this is helpful, is actually mapping to either a UID or a global concept for whatever, name your thing, and then you map all your data sources and or your vocabulary terms to that hub. So as an example, if you're working on a taxonomy and you have a center node that's UID 1234, it means in English cat, but in Spanish it's gato, and in this other data source they call it kitty. Right. So that's kind of what this looks like if that's the direction you're going. And also know that you don't have to do a perfect mapping each time. Depending on your use case, you could actually have partial, which is helpful for those pre-coordinated, right? So if you get a partial match, those are helpful, even if you don't use them in the machine learning, because then it gives you a smaller list that you can prioritize to go through maybe manually if you were doing everything else automated. Exact matches, of course, are better because they're exactly the same thing. And then associative are more like that see also kind of thing. And then no match, of course, there's no match. All right. So with that, I wanted to wrap up. I went, I think, a little fast, but that's okay. I went through a lot of things, so I wanted to make sure I left enough room for questions. So I will stop. Here's all of my stuff if you want to go and find me. Although I forgot, that's not my email anymore. So sorry about that. I have to update that. All right. So let me stop sharing and then ask, are there any other questions?
Ashleigh, I'm just going to jump in here since nobody else is looking like they're going to have a question for you here. But I mean, you mentioned data governance quite a bit, and certainly there's going to be others that are going to bring that up as well. But just tell me about your experience there and some of those key elements that you see, and obviously communication was one of those that you arose earlier, but maybe you can just outline a bit of those things that you see have been successful.
Yeah, I mean, I think that, especially when you're talking about like a data catalog kind of thing, I think that there's a lot of research and documentation out there on different approaches. But one way that I have found is incredibly helpful is finding a common need. And that sounds a little squishy, but I'll give you a real example. So this is hard enough in your own organization, but I was going in it was with IEEE, which is a standards development organization, if you don't know about it, on the computer and electronics side. And we were trying to create standards around the Internet of Things, right? So more linked stuff that you might all kind of understand or are aware of. The problem was we had to get all of and when I said we, I was working at a company called the Society of Automotive Engineers at the time, and we were collaborating with IEEE to create standards around the IoT. and data sharing. And there was this big meeting of minds where all the big players who were all competitors to each other had to get in a room, and they all were like, here's my cards. What are we going to share? I don't want to share my stuff, right? Like that moment, we've all been there, right? I don't want to share my data. It's my data. It's precious. It's mine. Don't touch it. It's my data, right? We're all like from the Lord of the Rings a little bit. But what got everyone talking was there is IoT. There is such a high demand and opportunity for what we can do here. Everyone started to say, okay, well, what data do we have that we would all need to have access to, right? A commonality. And then we started to piece through, okay, what things in there would be proprietary that we can't share? How do we want to share it? So I think that everyone does try to get around like one use case when they're trying to do a big data governance push, especially if you're doing like data catalog. But get really precise. I don't even mean like, oh, we all want to share each other's data. No, get way more specific than that, because then you can have more meaningful discussions about what is needed and what it's not. So those are my tips.
We do have a hand up. I'm going to try to hand Peter the mic here. Moment.
I worked in a lot of different industries. I'm more of a traditional data management guy, but about 5 years ago, I worked for GlaxoSmithKline on this IDMP project, which is reporting up here to the European Medicines Agency and then in the US to the FDA. And we were following 5 different ISO standards for substances, products, organizations, referentials, blah, blah, blah. And I'm just wondering if you have any comments about using some of these standards to borrow, let's say, predefined taxonomies. For instance, I was working in the substances areas, which was the most complex by far, and then, the EMA, or I don't know if it was the EMA, but they came up with it was ISO. They came up with a 500-page guideline and a lot of
course they did.
UML diagrams, blah, blah, blah. And I'm just wondering if you had any comments on how to use those, because Personally, I hate reinventing the wheel. I absolutely hate doing that.
Absolutely. And again, not pushing my channel over and over again, but I have a whole video on this. I find it incredibly frustrating when I start working with anyone that wants to get into the taxonomy space with vocabularies, or knowledge graph for that matter. And they're like, well, our stuff is so special and unique that we have to make our own. And I'm like, oh, here we go again. Because the word cat is not proprietary. It's not. And so the words you use are not as critical as the composition of what you're doing. So if you can go and see what others in the industry have agreed on for terminology, use it. You don't have to use the same level of abstraction, right? Like maybe their stuff is a little more broad than you need, so you can go deeper, or maybe they're going way too deep and you don't need to go that level. Maybe you disagree with how they have constructed, right? Like what things are nested underneath other things, like a parent-child kind of relationship. Change it. But what you do get when you reuse things is there are lots of other big brains that are contributing into that. And as those understandings refine, you get the benefit of that without having to crack the code on it. So what I say is, yes, please reuse, but do it at your own discretion. You don't have to use the whole thing. I've heard a lot of people, like FIBO is a good example. We have to use all of FIBO. No one uses all of FIBO. Nobody. Right? And so that's where a lot of these larger vocabularies are, like the Library of Congress. You would never want to use the whole thing. So you kind of can mix and match from it. So I also see, can you clarify what your definition of asset is? So asset is just a generic term for content, a thing, whatever a thing is in your organization. So your thing could be a document, your thing could be a person, your thing could be a gear that you manufacture, or a substance that you manufacture. So the thing is the lowest unit of measure that you would use in your organization that the vocabulary is describing. So that's what an asset is.
thank you so much for stepping in there last minute. Wonderful presentation. And again, these will be all on videos for those that had signed up to register for the event later on.
Wonderful. Well, thank you for having me, everyone. And thanks for the great questions.